Hello again, grade 11. We're on chapter 2, software. So let's get on with it. Right, so vocabulary, what you will learn. Okay, we'll find that out sooner or later. Types of operating systems. We all know about Android. The Android-based smartphone was the HTC Dream. Can you believe that? There's the first Android-based smartphone. Cool info there. Right, new words. Virtualization. The act of creating a virtual rather than an actual version of something. Utilities are small programs that help users to maintain their computers. Remember, utilities is part of system software. And system software is the computer, is actually a computer program that is designed to run a computer's hardware and application programs. So operating system is underneath this big term called system software. And in system software we have utilities and drivers. A driver is a set of instructions that tells the operating system how to communicate with a piece of hardware. The user interface is the operating system basically determines how people are going to react with your computer programs. Standalone operating system, basically an operating system that works directly on a single computer or a smartphone. And then a network one operating system is an operating system that's designed to help other computers in the network. And embedded is embedded OS means that an object, software or hardware, that is independent and does not need an external program or device to run it. Right, it's operating systems that are on things like washing machines, etc. Anyway, let's go back here. Software in a nutshell. Software translates instructions from your system software translates instructions from your program to a language your hardware can understand. Sends these instructions to the correct hardware, and upon receiving the instruction, receives information from the hardware. It receives information from the hardware. So your system software is basically responsible for all of these things, translating from your software to a language your hardware can understand. So translating from your program to noughts and ones, sending those noughts and ones to the correct hardware, and receiving information from the hardware, like when you click with a mouse or press a keyboard, sending it to your program. That's what the operating system software does. And allowing different applications to communicate with each other, and making sure all hardware and software are working correctly. So this is the function of system software. Right, the most important type of system software is the operating system that provides the user interface. Okay, so that's good to know. And then we have operating system functions or tasks that the operating system does do. So it manages and interprets signals sent and received by your hardware, and it communicates with the hardware using drivers, and manages your computer's memory and storage, monitors your hardware's performance, is all that the operating system does. Provides an interface so that you can interact with your computer, and allows the hardware to interact with the software, and allows computers to connect and communicate over a network. So standalone operating systems can work directly on computers. We know all about that. Network operating systems. And then embedded operating systems are operating systems designed to be used on a single device for a very specific purpose, like a smart TV or a video camera. The two broad categories of software, by the way, sorry about that, wrong tab. Two broad categories of software are system software and application software. Application software, all the programs that you use to do specific jobs like Microsoft Word, Excel, PowerPoint, Access, And what is an operating system? Definition of an operating system. The operating system processes thousands of small tasks to ensure your computer runs smoothly. It is the low-level software that supports your computer's basic functions, such as scheduling tasks and controlling peripherals. Peripherals is a fancy word for all the hardware that you attach to your computer. Right. So it manages the memory and the storage, and it monitors your hardware, provides an interface. Those are the three main functions of an operating system. It manages memory and storage, monitors your hardware performance, and provides an interface. And that is that. And it is possible to run two operating systems on one computer at the same time, and this is known as dual booting. It allows users to switch between operating systems depending on the tasks and programs they are working with. Right, types of operating systems. Well, operating systems can be classified into what is their description, their purpose, what is their cost, how large they are, what hardware do we need for that operating system, and then we have examples of operating systems that we're going to look at. Right, let's just look at this other question here. One difference between a standalone system and a network operating system. And that was, standalone systems make sure the tasks of the operating system are completed, and network operating systems help other computers on a network. So standalone is just worrying about one computer, and network is helping a whole lot of computers on a network. Right, types of operating systems. They play a critical role in many areas, and these areas are listed over here: hardware, software, processors, storage, memory, and networks. So your operating system is a very important program. And remember, it's a program and it forms part of system software. And we're going to look at three operating systems: standalone, network, and embedded. And there's an activity for you to go and look at and do. And this one as well, so we won't go into that. Make sure you do it and read your book while you do it. Now there's some new words here: machine code, binary, and hexadecimal. Well, these new words, machine code are the noughts and ones that are basically recognized by the processor and the computer, all the computer equipment in your on your motherboard. All programs have to be converted to machine code in order for the hardware to understand. It's an executable instruction code. And binary is just the noughts and the ones, the numbering scheme that we use in machine code uses to communicate, representing on-off switches, electric pulses in other words. And then hexadecimal is your numbering system of 16 digits, which we have actually done last year. We talked about hexadecimal. Remember, converting from binary to hexadecimal, or from binary to decimal, and so on. Right, programs in modern programming languages are much easier to understand than machine code. So machine code basically delivers directly to your CPU and is written in binary, in other words noughts and ones, or hexadecimal, which goes from 0 to 15. And hexadecimal has 16 digits and binary has only 2 digits. So binary is very basic, whereas hexadecimal is a little slightly more advanced. And yeah, your CPU can only understand code that has been converted to either binary or hexadecimal. So we call that interpreted or compiled code. So you know the Delphi language, which you used last year, and that code gets, it's very easy to write that code instead of writing a whole lot of noughts and ones or using hexadecimal symbols. It's much easier to write in Delphi code. So that code still has to be converted to noughts and ones, and they do it either by interpreting or compiling. So interpreter, you either have an interpreter to convert to noughts and ones, or you have a compiler to convert to noughts and ones. And basically, the programming language that uses an example of a program uses an interpreter is JavaScript. A programming language that uses compiler is Delphi or C++ and Java. It's all basic. There's a programming language called BASIC. And that was used on Apple computers many, many years ago. Right at the beginning. Now, anyway, so here we go. An interpreter will basically, what it does, it reads one line at a time, like reads one line of code at a time, and then converts it straight away into machine code and sends it to the processor to be CPU. So it basically interprets the program line by line, and the program starts running immediately. But when the interpreter finds a line that's wrong, then the program's just going to stop. But since every line has to be interpreted before it can run, the program's often going to run a bit more slowly than a compiled program, because it's sending it each time. Each line is sent one at a time and then goes to the processor. Whereas the compiler takes the whole code and checks it first and translates it first before it gets run or executed. So this compiler saves this code as an executable file. You must remember that Delphi has a .exe file. So when you run your program in Delphi, all that code is being converted into machine code. And by the way, they call source code your Delphi program, and the machine code is the noughts and ones, or the hexadecimal numbering system. Then that the CPU can understand. It first converts everything, checks it and converts everything, and then saves it as an executable file, and then you can run it on any computer without requiring the computer to have a compiler. Right, so here's some more differences between the interpreter and compiler. Interpreter sends the code to the CPU line by line. Compiler translates the whole program before sending to CPU. Interpreter is faster to open, but it's slower once it's open. The compiler is slower to open, but fast once it's open. And the interpreter continues interpreting and running until an error occurs, in which point the program crashes. The compiler will stop compiling the moment that an error occurs, which means the program never opens. Right, so you will be able to go and do all of those activities. Then Unit 2.3, Overview of Processing Techniques. This is very important because we have different ways of processing as well. Right, there's one very obvious one called multitasking, which means a processor is running many programs at the same time, but it's not actually running many programs at the same time. The CPU is so fast that it appears to be switching between, it switches between each program, does a little bit on one program and a little on the other one, and that goes so fast that it appears to be running at the same time. The processor can't work on more than one thing at the same time. One single processor can't do that. It has to switch between different programs constantly and gives the appearance that something is running at the same time. And that is called multitasking. So, but the concept of multitasking means that the CPU is going to run multiple tasks at the same time. We'll have multiple programs running and open at the same time. So if you want to listen to music while you're working, for instance, or you're listening to music on your computer while you're working, which you actually shouldn't do, but it works for some people, I guess. Yeah? Right, now the next thing is we have other different tasks that the CPU can do. The basic one is multitasking, okay? And then we have multiprocessing, and then we have multi-threading. Now we know what multitasking is, but multi-threading is when the processor allows the operating system to send instructions from different processors to a single processor. Okay. Oh no, wait. No, this is the. Sorry, I'm talking nonsense here. Operating systems allow this to happen. Right. The processor does the job. Operating systems controlling it, but with let's not talk about multi-threading, let's go to multiprocessing. Multiprocessing means you have more than one CPU. In other words, they call it a core, C-O-R-E. And that makes multitasking a lot faster. As you can imagine, each core has different programs that it's going to keep open. That's why nowadays you have many cores on your CPU. So 4 cores should be able to complete 4 times as many instructions as a CPU, only 1 core. In the old days there was only 1 CPU and the multitasking was not as efficient. So we call it multiprocessing. Having more than 1 CPU. So don't get confused between these two. Now, what is multi-threading? Multi-threading means one program is able to have many different tasks operating. So many different tasks inside the same program, and those are called threads. And the processor can quickly switch between the different threads of one same program. Each thread can be run independently executed when the CPU has time available between tasks. And a typical one would be Microsoft Word, where you have a spell checker running at the same time. You must notice that when you type in Word, it shows you immediately, oh, you've got a spelling mistake. That is multi-threading. The Microsoft Word program has its its spelling and grammar check running in the background. So that's a thread of Microsoft Word. And if you want to download, if you want to browse the internet and download a large file, then multi-threading would basically split this task of downloading and basically browsing the internet at the same time. So the CPU can quickly swap between the threads. So that's what that is. What's a core? It's a processing unit that receives instructions, performs calculations or actions based on those instructions. Basically, it's a CPU processing unit, and you can have many of those, and that's multiprocessing. Don't get confused between multitasking, multiprocessing, and multi-threading. Right, I'm not going to do that activity. We're going to move on to virtual machines and virtualization. Virtualization is the act of creating a virtual device, and the device acts as a node and is allocated its own virtual hardware, CPU, RAM, and storage. So you have virtual CPU, virtual RAM, and virtual storage space, and this behaves like a real computer. And if you want to create a virtual machine, your host machine has to be capable of hosting it, and you have special virtual software to do that. Your the virtual machine must have its own own operating system and applications installed. And different virtual machines also do not have access to the host computer or any other virtual machine. So why do we have virtual machines? We have different operating systems and a virtual CPU and a virtual RAM. Yeah, why would we want to do that? Well, it allows you to install another operating system on your computer. So if you want to test it out, and it won't interfere with your original computer. Also, if you want to test a program and to see if it has a virus or not, you can install it on a virtual machine, which has another operating system to your actual operating system. So you have a virtual operating system installing a virtual application to test to see if there's a virus in that virtual application. Not a virtual application. You have a virtual operating system which installs an application, and you want to see if that application has a virus so that it doesn't affect your computer. And if it does, then you can just delete the whole entire virtual machine without affecting your original computer that you're working on, the host computer. Right, now your image of the virtual hard drive can be used to back up your computer. So you can basically transfer your data to the virtual machine, your virtual computer. From your original computer, you can transfer data to the virtual computer and act as a backup. Now, the other thing with virtual machines, it allows any developers, in other words programmers, to create programs for Android or iOS without having to own hundreds of different devices. So that's another positive thing. But what is the negatives about a virtual machine? There are some negative things about it. These are the useful. The problem is that you have to have a very powerful computer in order to run a virtual machine. And there are disadvantages. Let's go and have a look at the disadvantages of a virtual machine. Oh my word, am I not on there? Yes, I am. The disadvantages are you have to have a powerful computer, your operating system and programs will run slower in virtual machines. And if you have a problem on your host computer, if you have a problem there, then that problem might cause a fail in your virtual machine as well. Might. Anyway. Alright, so that's that for today, and I'll see you next week, and work hard on the weekend and finish the quizzes before Monday.